Heat transfer and the definition of heat transfer. For energy transfer, energy can be transferred to or from a given mass by two mechanisms, that is heat transfer and work. Work also can be transferred. And for heat transfer rate, the definition is the amount of heat transferred per unit time. So if heat energy is Q, if the heat transfer rate Q dot is constant, so the heat transfer rate is Q integrated by dt or time. So Q equals to Q dot dt in joule. Heat flux is the rate of heat transfer per unit time, per unit area, normal to the direction of the heat transfer. So whenever you see heat flux, it is Q dot divided by area A. The unit is watt per meter square. Heat flux will be, the symbol of heat flux will be small q dot. And for power, the definition of power is the work done per unit time. So this one is about work and the time taken to do the work. Okay, what is internal energy? Internal energy is sensible in latent forms. You can see the sensible and latent forms definition in part 1. So the internal energy can be transferred as a result of different temperature and referred to as heat or thermal energy. So for example, our body have 37 degrees Celsius, then the heat can be transferred to the surrounding if the surrounding is low temperature, or the room temperature is about 24 degrees Celsius. But our body, the heat is not big enough, so it is difficult for the room to become equilibrium state. Okay, heat transfer, we have two cases of heat transfer. One is steady state heat transfer, steady state, and the other one is transient heat transfer, case 2. Okay, what is steady state heat transfer? It is heat flows continuously at a uniform rate. So for example, from hot to cold, the heat transfer is rate is 5 kilojoule per second, and after 5 seconds the rate of heat transfer is still maintained. So if you write the graph will plot like this, showing that it's constant. Okay, another one, to transient heat transfer, definitionnya the rate of heat flow changes with time. Heat flow changes with time. So for example, in the first 1 second, 5 kilojoule per second the heat transfer rate, but after 5 seconds the heat transfer rate is increasing. So when you write the graph, show the curve of increasing heat transfer rate or Q. And for heat transfer, we can predict the energy transferred from high temperature T1 to T2, when T1 is bigger than T2. Then if we know how heat energy is transferred and the rate of heat energy is transferred, then we can predict the energy transferred. Okay, for example, if you have rate of heat from steel, if you have steel bar and water that is 100 degrees Celsius and steel bar is 25 degrees Celsius, the heat will be transferring from the hot water to the steel bar. And then after 1 hour, the temperature of the steel bar have increased to 30 degrees Celsius, and the hot water temperature has decreased to 80 degrees Celsius. Then after some times, when the time is required, they will get to the equilibrium state, where the temperature of the hot water or the temperature source have become the same as the steel bar, 35 degrees Celsius. Okay, mode of heat transfer. There's three mode of heat transfer. One is conduction, the other one is convection, and the third one is radiation. What is conduction? This one, heat transfer through a solid medium. For example, if you have fire here, the heat of the fire conduct through this steel, and if you hold the steel bar here, the heat, we can feel the heat after some times. So the heat is conducted through the steel plate. This is by conduction. The second one, the convection, is heat transfer from surface of solid body to a fluid, or vice versa. Okay, it may be fluid or the air surrounding. So the heat from the fire can come to our hand by convection through air is being heated. And the third one is from radiation. This one is the continuous emission of electromagnetic energy that occurred in all bodies. So for radiation, there's no medium required. And can occur through a vacuum also, not necessarily air or water. It can be transferred through a vacuum.